Happy Earth Day. We are going to take this opportunity to take a closer look at some new data and facts about the environment. USAFacts has released their 2022 State of the Earth report, and we're going to dive into what the numbers are and what they mean. Here to give context to the latest environmental data, we have research manager at USAFacts, Nicole Bateman. I should make clear, USAFacts is a nonpartisan, nonprofit civic organization dedicated to making government data transparent, accessible, understandable to you and me. They are a News Not Noise content partner. Nicole, hi, thanks for being here.
Hi, Jessica. Thanks for having me. Happy to be here.
It is our first time talking on camera, but I've talked to you before off camera, and I got to say, you're very good at breaking this stuff down, so I'm excited to do this with you. I thought we could just start with the ugly stuff, fossil fuels, and I'm curious to help us understand, how has U.S. consumption of fossil fuels changed over time?
So fossil fuels accounted for 79% of U.S. energy consumption in 2021. So the data we have starts in 1949, and at that point, 91% of U.S. energy came from fossil fuels. So since 1949, we've decreased the share coming from these energy sources by 13%. And more than half of that drop actually has occurred since 2007.
Wow. So we've accelerated, and that's a sign that we can maybe do more in the future. Curious, what types of fossil fuels are we currently using the most, and how has that changed over time?
Fossil fuels include coal, natural gas, and petroleum. Petroleum is consistently the most common fossil fuel, making up 40% to 53% of the fossil fuels we consume in the US each year since 1949. So that's the big one. But we have seen some changes too in how we consume natural gas and coal. So from 1985 to 2007 thereabouts, the split between natural gas and coal was about even, but in 2007, natural gas started to pull away. So at that point, 28% of fossil fuels the US consumed were from natural gas. And by 2021, that was up to 41%, while coal has decreased over that period.
How about renewables? How much of our energy is currently coming from renewable sources?
So in 2021, the US consumed about 21% of its energy from renewable sources, and that's more than doubled since 1980.
Wow, that's impressive. What types of renewable energy are increasing? Anything noteworthy?
So I think one renewable to highlight in particular is wind. It is an increasingly common source of renewable energy. In the year 2000, it was 1% of renewable energy consumption in the US. And by 2021, it was 27%. So 1% to 27% over that time period.
Wow, that's surprising. Yeah.
It is surprising. Actually, as of 2019, we now get more renewable energy from wind than hydroelectric. And hydroelectric was actually the source of most of our low carbon energy from the 60s and 70s.
Huh, that's a great fact to save for trivia night. So let's zoom out a little bit. And you've said about 1/5 of our energy is coming from low carbon sources in the US. How do we stack up with other countries?
In 2019, the US ranked 5th among the world's 10 largest economies for its proportion of energy consumption from renewable and nuclear energy, both of which are low carbon. So among these 10 countries, France actually leads the ranking with nearly half of its energy coming from renewable and nuclear sources. Second place is Brazil with 38%, followed by the UK and Germany, who are just slightly ahead of the US. But then falling behind the US in these rankings are China, Japan, Russia, India, and Indonesia.
How has the US's ranking changed over time?
So it certainly has changed a bit over time. We sort of have stayed between third and fifth in these rankings since 1992, when the data becomes really more reliable. So we were fourth for most of the 90s and then fifth for most of the first decade of the 2000s. This last decade, though, got a little more interesting, though, because there was some more variability, more swapping, from third to fourth to fifth place. But when you dig into the data, you can actually see that a lot of that is because of changes in other countries and their energy mix, as opposed to the US energy mix changing much. So, for example, in 2011, the US moved up in the rankings because Japan took most of its nuclear energy offline in 2011 following the Fukushima disaster. So that's one example.
This is why I love USAFacts, one of many reasons, but you give us that context that helps us understand these changes. Okay, let's talk about emissions. How are we doing compared to other countries on our emissions here in the US?
In 2019, the only country that emitted more carbon dioxide or CO2 than the US was China. So we ranked second. Other top emitting countries.
Being high in that category is bad.
I'll let you decide that,
okay.
Jessica. You and your viewers.
Yes.
But other top emitting countries include India, Russia, Japan, Germany, and South Korea. But when we think about emissions, we also need to think about how much we're producing per person, right? So it stands to reason that countries with larger populations would produce more emissions than countries with smaller populations. At USAFacts, we looked at the 15 countries emitting the most CO2 and calculated their per person emissions. And when we do that, the US does drop a bit to the fourth most CO2 per person among these top emitting countries. But interestingly, we actually emit more than twice the amount of CO2 per person than China, even though China produces more overall.
And how has it changed over time? I know that we've emitted a lot of CO2 over the years, but can you give us some historical context?
I think one interesting way of looking at this is looking at all emissions from 1980 to 2019. So over this time, the US has emitted 1/5 or 20% of all emissions. Over the same period, the US has never comprised more than 5% of the total global population. So the 5% of the global population in the US has produced 20% of total emissions from 1980 to 2019. China is the only country that has produced a similar amount of CO2 over this period. And then between the US and China, there's quite a gap to the next country because no other country has produced more than 5% of the world's total emissions since 1980.
That is some grim data. Okay, let's look closer at the within the U.S. A little focus on how our states stack up. Do you have any insight into which states are getting the most energy from renewable sources and how they compare to the rest of the states?
Yes, I do. So there's actually a pretty wide range across the country in how much each state is getting from renewables and nuclear. There's from a low of 2% to a high of 55%. So New Hampshire and South Carolina are actually the states getting the highest share of their energy from renewables and nuclear. In 2019, it was 55% in New Hampshire and 46% in South Carolina. On the other end, if we look at the other end of the spectrum, 11 states plus DC get less than 10% of their energy from renewables and nuclear. And in Alaska, Delaware, and DC, it's actually less than 5% from these low carbon sources.
Which were those? Alaska, Delaware, and DC?
Correct.
Wow. It's so funny to hear that South Carolina and New Hampshire are on the cutting edge together, or most advanced in this category. They're such disparate states politically, but in the energy sector, it sounds like they're making real advances. I read that transportation was the largest source of U.S. emissions in 2020, the year of the pandemic, when we were mostly at home and often on lockdown, and we all thought that because we weren't driving, that's why, it would be a boon to the environment, that it still was the year in which transportation contributed the most. So can you explain why that happened, and is transportation usually the largest source of emissions?
Yes. So your instincts are right. Transportation emissions did dip in 2020 compared to 2019. They were down 13%, but emissions from other sources fell as well, which is why transportation stayed in this top spot. For example, emissions from electricity generation fell 10% and emissions from industry fell 6%. So to get to your question about whether transportation is usually in the top spot, this is a somewhat recent change. In 2017, transportation became the largest source of emissions in the US, overtaking electricity generation, which had been the largest source of emissions since at least 1990. But since 2017, transportation has been in that number one spot every year.
And was there any change for transportation from 2019 to 2020, trying to get at the pandemic's impact?
Yep. So transportation emissions dipped 13% between 2019 and 2020.
Right. You said, okay, got it. So is this all attributable to the pandemic, or are there other factors we should be aware of?
The answer is both. It was the pandemic and there were other factors. So as you said, the pandemic reduced how much people were going to work. Fewer people were traveling, and that reduced demand for petroleum. It also reduced emissions from the commercial sector because fewer people were going into office buildings, so there was reduced commercial building activity. The Energy Information Administration, who we actually rely on a lot at USAFacts for all this really great energy data, have also indicated that winter was warmer than typical in 2020, which reduced demand for heating. So that's a non-pandemic reason why emissions were down in 2020. And then another reason they cited is that the mix of fuels used in electricity generation also changed. So we used less coal to generate electricity in 2020, and coal produces more emissions compared to other fuel sources. So we saw some reductions from that shift.
That's fascinating. One of the bright spots when we talk about the environment are our national parks. So let's just spend a moment on that. How did the pandemic impact our national parks?
I think we heard a lot in the media about people getting out more. I know I personally was trying to get out more into nature during the pandemic, but visits to national parks actually did fall in 2020, largely due to temporary park closures and restrictions that were implemented during the pandemic. So between 2019 and 2020, visits fell from 277 million to 205 million. This wasn't universally true, though, because some national parks actually did receive more visits, including Shenandoah and the Indiana Dunes National Park.
I love how much data you have. Okay, so 2021 was the sixth warmest year on record. I feel like this is a Jeopardy question. What are the top 5 warmest years on record?
Yes, definitely. I feel like this could be a trivia question for sure. So I hope people are taking notes.
Your notes.
So the 5 warmest years on record have all occurred since 2015. So in that number one spot is 2016. It was the warmest year on record, followed by 2020, 2019, 2015, and 2017. And then, as you said, 2021 was in that 6th place spot.
Wow. This is an upsetting data point, but every U.S. state, every single state was warmer in 2021 than the 20th century average temperature. Is that correct?
Yes, that is true. Every state was warmer in 2021 than normal.
So would you break down for us, what does that mean? What are we measuring?
Yeah, absolutely. It can be kind of confusing, and this is an important thing to understand. So thank you for asking. I'll illustrate with an example. So in 2021, North Dakota, Minnesota, and Maine were the warmest compared to their 20th century average. So they were more warm than normal. This doesn't mean that they were the hottest states in 2021. That's not what we're measuring here. Rather, we're talking about the average temperature these states experienced over all of the 20th century compared to the average temperature they experienced in 2021. And it's that difference that made these states abnormally warm last year.
You guys have so much information. I really think we should explore this whole trivia idea. Maybe there's a way to gamify the data.
There might be. Right? I'm sure we can find it.
We'll get into that later. Nicole Bateman, I'm so grateful for your time today. I'm so glad you've joined the team. Thank you for being here today and for breaking all this down for us on Earth Day.
Thank you so much, Jessica.